Hi, everybody. Today we're going to start our unit on decimals. So in this first video for our lecture notes, we're going to do an introduction to decimals. And specifically, we're going to cover place value and rounding in this video. Now, decimals are just another way for us to express parts of a whole, just like fractions are. So decimals or decimal notation. So decimals or decimal notation allow us to express parts of a whole, just like fractions or fractional notation. And we're actually going to see, not in this video, but very soon, that we can go back and forth between decimal and fractional notation relatively quickly. A little bit of work obviously is required there, but we can switch back and forth between the two forms. So both forms are really nice. They both have great times that we kind of want to use them. So fractions we tend to use more if we need specific values. So if the decimal is a very long decimal that requires us to round or to truncate it, then sometimes the fraction is the more accurate answer. We obviously also use fractions for things like baking, or if you're thinking about cutting material and things like that. So if you're in construction, you're using fractions all the time, not decimals. So there are places where fractions are better. Decimals also have their place, right? So the biggest one here is money. So we use decimals all the time with money, right? So change is out of 100 cents. So we use decimal notation for that. And again, that's just one example of how we use decimals on a regular basis. So both are good forms, and here's just another one that we're going to talk about. Now, let's just start with a quick example here. So here's an example of a number in decimal notation. And the first part here is obviously your whole number. And then you have your decimal point. And then after that, you have the decimal part of the problem. Okay, so that point, that 236 here, that is your part of the whole, right? So 15, we have 15 wholes, but we also have this 0.236 after that. So we have a little bit more than 15, but not enough to make that 16 wholes. So that is your part there of the whole. Now, we do need to know how to read this, right? So I just set it to as 15.236. And a lot of times in math, I won't lie, we do read our decimals like that, particularly if it's a long decimal, and I just need to make sure that you write it down correctly. So you will see us kind of, the lazy way is to just say 15.236, but there is a correct way to read our decimals. And we need to know our place values to do that. So let's start with our place values, and we're going to build off the original place values that we started with whole numbers, but we're just going to extend it now into the decimal form. So I'm going to turn my paper probably sideways here while I'm writing with you guys, just like I did before, and I'm going to go through all of our place values. So I'm not going to, I shouldn't say all of them. I'm not going to go through every single place value in the world, obviously, but I'm going to go through the main ones here. So I'm going to start with our whole numbers first, just to kind of review the first few of those, and then we'll go into the decimal form. So we have, I'm going to go up to millions here for our whole numbers. So we have our millions. Then we have 100,000s. Ten thousands, thousands, hundreds, tens, and ones, and that completes the whole number part of it. Again, I know before when we did whole numbers originally, we did extend this a bit further, so there are more place values there. Obviously, we can go up to the billions, trillions, and so on. But again, I'm just going to do the first few here to help us stay organized. All right, now after the ones, what I'm actually going to do here is I'm actually just going to put a little placeholder and put my decimal point there, just to kind of separate where the decimal part comes in. And now let's go through those place values. You're going to notice there is no ones equivalent on the decimal side. We jump right in with the tenths place. After tenths, you have the hundredths place. You have the thousandths place. You have the 10,000ths. Place. You have the 100,000ths. And then we'll go out to millions. Place as well. Now, again, obviously you can keep extending here if you need to, but for our purposes, this is usually probably as far as we're going to go for most of our examples. So this should be sufficient. Now, there's a couple things I want to point out here. So after the decimal point, you obviously have the decimal part. So this here is your decimal part. And I want you to notice that each of the decimal parts ends with a THS. And this is really important. You don't have that on the whole numbers. Let me show you the whole numbers. So whole numbers don't have that TH at the end. They end with the DS in most cases here, except for obviously tens and ones. But on the decimal part, you're going to see that TH. So that is how you can distinguish between, are you in the whole number section or the decimal part section? If you have that TH at the end, whether it's read or written, now you're in the decimal part. So on the other side up here, again, here you have your whole numbers. Oops, whole number part. Okay. And again, notice the ending, right? We're not ending with a TH. Usually it's a DS, but sometimes it's just an S depending on the word. And the decimal point here, I'm just going to put this in, is often read as the word and. So if you remember back to whole numbers when we were actually writing our decimal, our whole numbers in words, excuse me, we didn't use the word and. We would often put commas in between to note the different place values if we have to, if it was getting kind of long, but we didn't use the word and. So we do use the word and when we read things with fractional or decimal parts. So if I was reading a fraction, maybe it was a mixed number, 2 and 1/2, I would say and before I said the fraction part. So 2 wholes and 1/2. If I have a decimal, again, I would use that decimal point, I would use the word and there so that I'm signaling that I'm changing to that part instead of the whole. All right, now one last thing I want to add here for the decimals is I do want to kind of do a little bit of the notation in math as well. So when you say 1/10, that represents the fraction 1/10. So I know when we say 10, you're thinking about the number 10, right? But tenth is 1/10. Hundredth is 1/100 instead of just the number 100. Thousandths is 1/1000. 10,000ths is obviously 1/10,000. 100,000ths is 1/100,000. And millionths is going to be 1/1,000,000. Okay, so when we have the decimal part, instead of just having the actual number, you're putting that number in the denominator. So, and this is going to help us later to transfer into fractional notation. So that's an easy way for us to go back and forth, and just by using the wording there to help us transfer over. So these are your different place values. So now, if I look at an example, let's get a different color. All right, so let's go back to our example here. And what I'm just going to do, I'm going to just line it up in my place value chart. So there's my decimal. After the decimal, I have that 236. And before the decimal, I have the 15. Okay. And what I do recommend, you know, if you are having trouble kind of reading your decimals at first, then take this place value chart, copy it over on a note card or something easily accessible for you, and then you can actually write your decimals in below it, and that will help you to learn how to read them as well. So we kind of read the two parts separately. So you read the whole number part, and then you read the decimal part. So this obviously is the number 15. We use the word and there. And then what you do is you read this almost like a whole number, but then you put the final place value at the end. So this number 236 is 236. So I read it as 236. And then that 6 lies in the thousands position. So I add that word thousands on the end. So this number, although like I said, we often just say 15.236, really we should read it as 15 and 236 thousandths. Okay, so each part gets read almost like a whole number, but on the decimal side, whatever place value you end in, that's the one that you're going to express. So here we're in the thousands position, so we say thousands at the end. All right, let's do another example. Let's see, do it down here. So I'm going to do it with a negative number 2. So negative, and then I see 333.12. So how do I correctly read that? And again, if you're having trouble, use your place value chart and write it in first. So my decimal is here. So that's my and. And then I have the 12. And then I have the 335. Now again, that's negative. So just keep in mind that you have a negative value here. And again, if you need to kind of extend these down, you can go ahead and do that. So we read it in two parts. We read this number, the word and then this number. So here, this is 335. So it's negative 335. And I have to be careful too. I always throw in the word and there by accident myself, just from speaking it for incorrectly for so many years. So it's 335. And now we put the word and in for that decimal. This is the number 12. I'm gonna write down here. And it ends in the hundredths position. So I write 12 hundredths. Okay, so that's how we would read that number or write it in words. So negative 335 and 12 hundredths. So that word and goes in between the decimal. And I know for myself too, that's a really tough habit for me to break because I always grew up, you know, reading something like 335, right? Which is not right. That's incorrect. But that's how I kind of grew up reading it and was never corrected. So that word and should really only go for the decimal. Or if you have a fraction, it would go after the fraction, right? So I know we're not doing fractions here, but like I said before, if you have something like this, you would read that as 2 and 1/2, right? So that word and is where you distinguish between your whole number part and your decimal part. All right, I don't want to drive that home too much, but I like to make it a point because I say it wrong myself sometimes. And again, it's just from doing it my whole life and no one ever correcting me. So even though I teach math and I have 2 degrees in mathematics, it's still something that I have to learn to break myself. So when we're careful, particularly when I'm writing, I make sure that word and is only going on the decimal position there. And of course, we can also go the other way. So let's do an example. So maybe I have it in words first. 26 hundredths. Okay, so 48 and 26 hundredths. So again, that word and is going to tell you where that decimal point goes. So on the left side here, I have the number 48, which looks like this. On the right side here, I have the number 26, and it needs to be in the hundredths position. So if you go back to your place value chart, if you find that helpful, the hundredths position is 2 positions in. So that 26 ends in the hundredths position, right? So I have tenths and then hundredths. So it's going to look like this, right? Because here's the tenths and here's the hundredths. So we end in that position. Now I want to do another example that's very similar, but show you something to watch out for. $48 and 26,000. So again, that and is going to tell you where that decimal point goes. And 48 stays the same. And you're still seeing that number 26. So you're like, okay, this is the same problem. I just put 0.26. But it's not the same problem. Here I have the thousandths. So your 26 needs to end in the thousands position. So if you look here, my thousands position is actually 3 spots out, not 2. So it's like, well, how do I do that, right? I need to go 3 spots out to put the 26. So sometimes I like to do this. I'll put, there's the tenths, there's the hundredths, there's the thousands, right? Here's the tenths, here's the hundredths, here's the thousands. Okay. Now I have to end in the thousands position. So this is 26, it's just 26. So think about how to write it. I need to end here. So it's gonna have to go like this. So what do you do if you have something like that, but you have a gap here? You put in a 0. So you want to be really careful. This is where it gets a little tricky. The place value that's given is always where that decimal point or that decimal part ends. So start at the ending point, and then if you have a gap in the beginning, you can fill in with zeros. So for instance, again, I'm going to do another hard one like this. Maybe I have 200 and 5 thousandths. So start with what you know. That word and is going to give you the decimal. 200 is 200. I have the number 5 here, so that looks like that. But I'm in the thousandths position. So again, if you need to go back to your place value chart, how many positions is that out? Well, the thousandths position is here. So that's 1, 2, 3 spots after the decimal. So I need to go 1, 2, 3 spots after the decimal. Well, all I have is number 5. So that 5 has to end in the thousands position, and then I fill in with zeros. Okay, and again, just watch out for these. These ones get a little bit tricky. So if I start with this number, I would still read it this way, 205 thousandths, because you're in the thousands position. All right, so the next thing I want to do in this video is talk more about rounding. And we've seen decimals before. So actually, I'm going to go back to my first page for a second. Let me just title this part place value, just to make it a little bit clear. All right, so now we're going to do rounding, and we've seen rounding before. So the same rules are going to apply. We're still going to basically underline the part that we're trying to round to. We're going to look to the position to the right of it and let that tell us if we should round up or keep the underlined value the same. So the only thing that's really different is we don't end up tacking on a lot of extra zeros. So I know when we're rounding for whole numbers, we replace anything to the right with zeros. And you can do that here, but we don't need them if they're just extra zeros hanging out after the decimal point. So I will show you. Let's rewrite our steps, and then we'll go through some examples here. Okay, so we're going to underline the place value you want to round to. And then you're going to look at the digit to the right of the underlined number. If this digit is 5, 6, 7, 8, or 9, we're going to add 1, just make this capital, to the underlined number. And this is the idea of rounding up. And if this digit is 0, 1, 2, 3, or 4, you're going to leave the underlined number as is. So technically this is called rounding down, right? Although you don't actually change the underlined number, right? You don't subtract anything with it. Okay. And then what we're going to do here, which is a little bit different, is we're going to actually drop all digits to the right of the underlined number. So with whole numbers, instead of just dropping them, we had to make them zeros. But when we're to the right of the decimal, extra zeros at the end of the number aren't going to make a difference. So for example, something like 5.4 is the same as 5.40, is the same as 5.400, the same thing as 5. With the 4,000 afterwards. So by tacking on extra zeros, again, to the end of the number, so not in between, but to the end of the number after the decimal, which is key, after the decimal, it doesn't make a difference. So we don't have to write all these zeros in, we usually just drop them and make it a little bit easier. All right, let's do a couple examples. All right, so we're going to round. $17 and 289 thousandths to the nearest tenth. So I'm going to do the same thing I've really done before. First step is to underline the position that I want to round to. So I'm rounding to the tenths position. Now, again, if you need to take out that place value chart to see what position you're in, then go back and take out your place value chart. Keep it with you for a little while until you're comfortable with this notation and the wording here. So our tenths position is the first position to the right of the decimal. So we're looking at this position being our final digit. And we look to the number to the right. So 8 is a big number, right? It's in that 5, 6, 7, 8, 9 category. So it's going to take that 2 and bump it up. So this becomes 17.3. And now instead of making the remaining digits 0, like we did with whole numbers, we're just going to drop them because it doesn't make a difference in the value of the decimal. We're going to round to the nearest hundredth this time using the same number, 17 and 289 thousandths. Again, notice that, see that TH at the end, so I know I'm rounding to a position after the decimal point. And the hundredths is 2 spots in. So the hundredth position would be the 8. I look at the 9, that also happens to be big, so it's going to bump that 8 up. And I appoint to 9. So let's do the same number again, but this time round it to the nearest whole. Now, when we say the nearest whole, that typically means the ones position. So just to kind of review here, Your nearest pole or your ones position is actually on this side of the decimal, but it works the same way. You still look at the value to the right. This is small, so technically you're rounding down here, right? So this is just going to stay 17. And then we drop everything else. So you don't, that scared me, hang on. All right, everybody, sorry about that. I think you're all probably laughing at home now at me jumping when the phone started ringing here. I apologize for that. So here we have our final answer of 17. And we do also drop the remaining digits. So because the only digits left are after the decimal place, right? So we don't really need to put a decimal in like that. Doesn't really make sense. We can just leave it as 17. All right. If you are rounding, just as a little review here, to the nearest 10, so do note the difference. We're not saying tenths, we're in the tens position, and that is right here. So again, I'm just kind of doing a little bit of review with those whole numbers too. So if you don't have a TH at the end, like we did in these first two, then you're on the left side of the decimal point. If you have a TH, you're on the right side of the decimal point. So here I'm to the nearest tens position. That 7 is going to be big, so it's going to bump this up. So that 1 becomes a 2, and you do need to fill in any missing digits on the whole number side with zeros. So this becomes 20. But you don't need to fill in zeros after the decimal point. So I just want to make that distinction really clear here, that if you're rounding on the left of the decimal, so in the whole number part, then you do need to fill in any missing digits with zeros, right? Because 17 is not 2, it's close to 20. But on the right side of the decimal, we don't have to fill in zeros there for anything after the digit. So just kind of a little reminder there as you're rounding to note those differences as well. Now, let me just do one more example here with a negative. So let's round negative, right? And this is 0.23485. So if we read that, let's see, we're at 23,485. And if I go back here, I'm 1, 2, 3, 4, 5 positions out. So 1, 2, 3, 4, 5. I'm in the 100,000th position. So I would read this as negative 23,485 hundred thousandths. So that's how we would read that. And we're going to round to the nearest thousandths. Now, that negative when you're rounding is not going to make any difference at all. So the thousands position is 3 spots out. Again, get out your place value chart if you need to. So we're going 1, 2, 3 spots out. The number to the right is an 8, which happens to be in that big category, so it's going to bump this up. My leading digits all stay the same. The 4 becomes a 5, and because I'm to the right of the decimal, I drop everything else. So I'm going to round this to about negative 235 thousandths. Okay, so again, just watch out for that slight change in wording because it does make a big difference here. Okay. One last thing here, just kind of a quick little application. And we'll see this formula later. Ooh. There we go. But we do have a number pi, which some of you have seen, I'm sure, before in classes, which is, so first of all, it's an irrational number, which means it doesn't repeat or end. So it's just a number that has a decimal that continues on forever and ever and ever and ever. And there's no repeating pattern. Like there's no pattern to it where, you know, you can predict the next value. It's just always changing. There's no pattern. So it does continue on. And it is about 3.14159.265. And again, this keeps going on forever. And we use it a lot with circles. So for instance, pi is actually equal to the circumference of a circle divided by the diameter of a circle. So here's my circle. Your diameter is our center. So your diameter is the full way across. And then the length around the circle is the circumference. So it's actually a fraction or ratio that compares those two things. And just as a little side note, halfway across the circle, that is a radius. So I'm sure many of you have heard that phrase as well. So pi is a number that we see a lot in mathematics, and a lot of calculators can actually store quite a few digits of pi in them. So if you have a calculator that has the pi symbol on it, then your calculator is doing pretty well. It has quite a few digits of pi already there, but a lot of times we just round it. And most commonly, we end up rounding to either 2, 3, or 4 decimal places. Sometimes 5, that tends to be the usual. So we don't usually use much more than that if we're just doing an approximation example. So let's do one example here, and let's round to the nearest hundredth, because we do use this a lot. So I'm going to take that approximate value for pi. I'm going to the hundredths position, which is 2 spots out right here. My next number is small, so that's in like that round down category. So it actually just stays as a 4. And then my final value is going to be about 3.14. So you may see a lot of times that we end up using 3.14 for our value for pi, or like I said, usually we use between 2 and 5 decimal places, most commonly in examples, but for the easier examples, we tend to just use 2. So you may see 3.14 a lot to represent pi when you're dealing with circle formulas, but do note that it actually does continue on forever, and it's a special kind of value.